Welcome back to Miss Teacher 2 with Mrs. Leon. Today we're going to be talking about buoyancy force. Now, buoyancy force is very interesting. The greater the buoyancy force, the more an object will pop to the surface of water and rise to the top. The less buoyancy force, the more gravity will take over and will pull objects to the bottom. So today we're going to look at submerging bottles at different depths inside the water. So again, the greater the buoyancy force, the more it'll cause an object to rise or float to the surface. The less buoyancy force, gravity is going to take over and suck it all the way down. Watch the next experiment and see how it works. Make sure to make predictions and log your observations. Welcome back. So before we get started trying to get things to float at different levels in the water, we're going to first experiment with a couple of different containers. I have a plastic water bottle and I have a glass jar. Both of them have lids. Before we get started, I'd like you to draw these two items, if you haven't already, before I get started. So the first thing I'm going to do is I'm going to work with the jar. And I'm going to see if I can get the jar to float by keeping the lid all the way on nice and tight. And you can see with the lid on, I have absolutely no problem getting that jar to float. It's partly submerged in the water. That means it's partly underneath the water. But for the most part, it is floating on top of the water. I'm going to take the same jar and I'm going to take the lid off. And I'm going to put the jar on the water. Now you can see if water gets inside of it, it's slowly going down. Let's see what happens if more water goes inside of it. Oh, there, it's all the way at the bottom. Let me see if I can just get it to sit on top. Well, I can, but it does want to tip to the side and take on some water. Okay, so not bad. It obviously floats better with the lid on. Our next bottle that we're going to try is the water bottle. Now water bottles are made of very thin plastic, so they're a lot lighter than the glass. Let's see what happens with this one. Well, with the lid on, it floats right on top of the water quite nicely. Let's take the lid off and see if it can do the same thing. Lid off. Yeah, it's got no problem staying up there either. What about if I push on it a little bit so it takes on some water? I wonder if it'll stay on the top then. Let's try that. Oh, it's about half full and it's about half submerged. And again, submerged means underneath the water. Think of submarine, submerged, and that'll help you remember what that word means. Okay, if I put it all the way full of water, what's going to happen? Well, it goes right to the very bottom of the tub. Okay. I'm sure a lot of you have played around with all kinds of toys in the bathtub at home. This is a great experiment for bath time. Well, not with the glass, of course, only with plastic items and only if mom and dad say that's okay. So I'm going to leave you there. Our next experiment, we're going to try to get this bottle to float at 3 different levels in the water. On top, in the middle, partially submerged, and way at the bottom. Okay, so for this experiment, I've got the same bottle. I'm going to take the cap. Well, obviously I can get it to float right on top if I keep the cap on. That way absolutely no water gets inside and I get to keep a nice big air pocket inside my bottle. So it's floating like way up high on top of the water. We're going to try to submerge it halfway. So not all the way sunk, halfway. So for that, we're going to have to take on just a certain amount of water. Make sure that you are drawing these observations that you're making, drawing diagrams as we go along of the different heights in the water. Well, that's not partly submerged. Whoa, that's very cool. It's upside down. Can you see the water line down there? That's very cool looking. But what I want to do is get halfway. Oh, that's not bad. That's kind of partly submerged right there. Not all the way down, not all the way up. Let me see if I can take on a little bit more water and get this to go all the way to the very bottom. It's still got a little air pocket in it. That air seems to want to allow it to come back to the top. So it seems like the more air that's inside of our container, the more buoyancy force it has, and the more it is able to fight against gravity and come back up to the surface. So you can see if I fully fill my bottle, I can get it to lay right on the bottom at the lowest depth inside our tub of water. Very cool. And again, with no water, it's right on the top. And it seems like if I fill it halfway, it can be partially submerged and kind of hang out there in about the middle. That's very cool. Let's see what happens with our jar. Remember, glass is a lot heavier than plastic. And again, don't try this at home with glass. It can be very dangerous. If you want to do any experiments at home with glass, make sure mom and dad are helping you and you're not doing these things by yourself, because they can be quite dangerous. So here, if I keep the lid on, you can see a little bit is underwater, but the majority of it's at the top. So this would have a pretty good buoyancy force, pretty high buoyancy force to keep it up there. And again, by keeping the lid on, I'm keeping a very big air pocket inside of it. Now I'm taking the lid off, and on its own, oh, can you see that? On its own, it wants to partially fill with water. See the line of water inside of it? And again, it's partially submerged. A little tiny bits at the top, but most of it's hanging out at the bottom. If I fill it all the way with water, down it goes. So air helps things float a great deal. Again, let's see what that does on its own. There, it's partially submerging. Fully submerged. Okay, well, that concludes our experiment. Make sure if you're trying these things at home, mom and dad are helping you. That's all for now. Well, we certainly have learned a lot about sinking and floating in this particular lesson. Now, let's just review some of the things that we've learned. We learned a lot about water and air pockets, and that when we put the lid on our container and there was air inside, it created an air pocket. And it allowed our container, whether it was a heavier container like this or a light container like the plastic one, to float on the surface of the water. It became more buoyant. It increased the buoyancy force, therefore it allowed it to get higher and higher in the water. We also learned that heavy things like the ships behind me, especially that massive one that keeps going and going, that too uses air pockets so that that boat can keep right on floating. That thing is huge. There's even cars on the end of it. So what I'd like you to do if you're practicing any of these experiments at home, make sure your mom and dad give you help. Make sure you're not using dangerous things like glass containers unless mom and dad are supervising you and helping you out with that. Again, if you'd like to learn more and you enjoy these videos, please like and subscribe, and that way you'll get notifications as I add more videos to my collection. Thanks for watching.